Well, good afternoon, good evening, good morning, wherever you happen to be around the world, and welcome to another Agency Success live stream from hosting.com. My name is Nathan Ingram. I'm the Agency Success Coach here. I'm also an agency owner. I've been working with clients since way back in 1995, building websites. And so we're talking about a topic today that over the years has caused me much grief and frustration. And as I talk to folks who do what we do, building client sites on the web, DNS is always one of those pieces of knowledge that seems to it's confusing to everyone. We did a quick informal poll in the chat, totally unscientific, about who has experienced a problem with DNS in the last 6 months, and it was about half, and that's about what I figured. If you haven't experienced a DNS issue in the last 6 months, your time is coming. So we were just talking even last week during office hours about how critical DNS failures affect the web. Just last week, a lot of Amazon AWS went down, and it was because of a DNS problem. So even the big boys have problems with the DNS. And so what we're going to do today is unpack this really complicated subject and hopefully give you a little bit of clarity that will let you do DNS better and with more confidence. So again, if you're just joining us, I'm going to drop in this slide link one more time before I start rolling. In the chat, you will find the link to download this slide deck, and it's got some links later that might be helpful to you. So make sure you grab that. So why is it that why does DNS actually matter? So DNS is the hidden system that makes the internet work. It's what connects websites. It lets you access websites through your browser. It is the connecting tissue behind all the servers on the internet. DNS stands for Domain Name System, and you might think of it like this. DNS is like the plumbing of the internet. Nobody thinks about it until something breaks, and then the results are about the same. And if you're confused about DNS, it's not just you. DNS is very confusing. Even if you've been doing web for a long time, it is still really easy to make DNS mistakes if you're not careful. So here's where we're going over the course of the next 45 minutes or so. We're going to unpack what DNS actually does, all the little pieces of the DNS puzzle and how they fit together, how DNS works, including especially name servers and propagation. And then we'll wrap it up with some pro tips that I've learned over the years of making all the DNS mistakes myself. And the goal at the end of this time will be hopefully to grow your confidence in handling DNS issues. So that's where we're heading over the next few minutes together, and I'm really glad you've joined us today. So let's talk about what DNS actually does. And to understand this, we need to go back in time to the point where the internet was a text file. Did you know that was a thing? So way back in the 1970s, there was this thing called the ARPANET. It was the US military and their DARPA division created this network of computers that could talk to each other at great distances. And this entire ARPANET was managed by a single file called a hosts.txt. And this is the map of the ARPANET back in 1977. You can see there's a lot of computers connected, but just a mere fraction of the computer, all the servers that are connected on the internet today. And this entire network was run by a single text file called hosts.txt that listed every single server on the network and its IP address. Now, when you have this many computers, well, I mean, that's doable, right? But as the network started to expand, it became quickly obvious that distributing every computer's location on the network by a single file is just impractical. So way back in 1983, the DNS system was designed as a distributed, scalable naming system to manage the growth of this ever-increasing network. I don't think they dreamed that an internet would be possible like it would be today. Maybe some people did, but this is how it all started. It goes back to a single text file. And how can one server find another server? And if I'm making a request, how can I make sure that my request is getting to the right place across this vast network of servers? So the best analogy that I've come to understand, the best way to explain DNS is like this. Think of DNS like contacts on your phone. If you were to pick up your smartphone right now and look at your contacts app and see a person's contact information or a business's contact information, you might see something like this. Well, here's Jenny's telephone number. And way back in the day when I was little, we used to have a phone list, beside our home phone back when we even had home phones. And you had all these people's numbers written there. And you had to remember their phone number to actually dial or press in the numbers to dial that person on the phone. Now, today, you can just pick up your smartphone and say, call Jenny, right? We don't have to remember the number. We just have to remember the name. And that's how DNS works. DNS is the translator between what we type and where servers live. So instead of having to remember 142.250.9.101, we can simply type google.com and we'll get to Google. That's the way DNS works. It's a shortcut, so we don't have to remember IP addresses, which, I mean, we don't remember those things, right? So it's a good analogy. There's a lot of pieces, though, that go into making all of this work. And it all starts with an organization called ICANN, which is the Domain Registry. That's an acronym that stands for the Internet Corporation for Assigned Names and Numbers. Now, this is a global nonprofit. They oversee the entire DNS system of the Internet. Now, ICANN manages what are called the root servers, the master domain registry. It's like if we go back to our phone analogy, those of you that have been around a while, you remember the phone book, right? Like you had this gigantic paper book and you flip through it and you could see every person's name and their phone numbers listed, right? That's what ICANN manages, this gigantic, all the websites, all the domain names, and what servers they point to, or what name servers control that domain name. That's what ICANN does in this giant thing called the registry. They're like the phone company that ensures that every name is unique. Just like, the phone companies today, even for mobile devices, only one phone has that particular number that you have. So you dial that number, it gets your phone. And so ICANN in the registry makes certain that no domain name is pointed, like they're all unique. And so we can identify the right server with a particular domain name worldwide, with all the millions and millions and millions of sites that comprise the internet. Now, working alongside this registry are companies that are called registrars. Now, these are for-profit companies that sell domain names to customers like Namecheap, GoDaddy, Porkbun, whatever. These are the ones that handle the customer service side of this. They must be accredited by ICANN, and that's a pretty detailed process. It takes a big application and demonstrated financial and technical capabilities and an agreement to a registrar code of conduct, basically. And they can set their own prices. So they retail domain names plus an ICANN fee to, that kind of kicks back up to make sure ICANN can operate with funds. And this registrar, their job, when you buy a domain name, they insert it into the registry. That's their whole job. And then to have customer service if there are problems. So these are the first two pieces, and you're probably familiar with these. You have your favorite domain name company, your favorite registrar that you work with, and you buy a domain name, they stick it in the registry. And then we get into the next piece of the puzzle, the biggest piece probably in my opinion, and that's the name server. Now, the name server is really at the heart of DNS. That's where we're going to spend most of our time. We're going to unpack this all in just a few minutes. But this is where the actual DNS records live, like A records and CNAMEs and MX records. So the registrar, you buy a domain name, it inserts it into the registry, and then your registry is going to look up the name servers for that domain name that then tell the browser where to go look for all the things. So your name servers are a critical piece of the puzzle. They decide where to send traffic that comes into a domain from a web browser request or other app request. Now, finally, we have the web host like hosting.com that provide the server where the website's files and database and other resources live. The name server points the traffic at the web host. Now, they provide an IP address for all the resources, and that IP address is then added to the name server in domain records, DNS records, so that it tells the browser or app or whatever where to access the resources that you're looking for. Now, that's how it all basically works as all the pieces of the puzzle. Now let's take it a little bit of a step further to see practically how it's all going to happen. So we're just going to take a web browser, for example. You type in google.com or whatever into your web browser. Your web browser goes out to request a website. So what the browser is actually doing is saying, first thing is, I need to find the name server for this domain name so I know where to point to what IP address to get the information I'm looking for. So we have to get the name server for the domain name that we entered, so that because the name server knows where to send that request. Now, how does the browser figure out where to find the name server? Well, that request is going to travel through several layers of DNS servers. And here's where things get complicated, because all these layers of name servers are really good for the efficiency of the internet, but this is where all of our problems come from, because there's caching involved. So this request, I'm going to go to google.com. Where are the name servers? Now I've got to go look through several layers of servers to find the actual name server. There's a DNS server in your web browser. There's a DNS server in your operating system like Mac or Windows or whatever you're using. Then you have what's called a recursive resolver, like your internet service provider, or maybe you've entered Google's IP addresses or Cloudflare or OpenDNS or something like that, like in your home router or on your particular device. So that's another layer. And then at the very top, or really bottom of everything, are the root and authoritative DNS servers from the registries that ICANN maintains and your registrar maintains and all of this. So there's all these layers of DNS. And this is why, wow, things take a little while to filter their way through all of the web of DNS servers. And so this is where some of the problems come that we encounter, because each of these layers is important. Like it's faster and to look up things in your browser or your operating system, then it gets a little slower the further down you go. Every layer is caching for speed, but if you change something, there's often a delay in getting those answers back to your browser because the caches have to update. Now, here's a little better visual of how this all works. So let's say, you type in www.domain.com. We got to find the name server for this domain. So the first place this is going to look is the internal DNS for your web browser. I'm going to show you this in a little while. It's internal to the browser. It is really, really fast. And you can really think of this as your own little, like the original internet, when the whole internet was a text file. Your browser has a little miniature database, or really a flat file of this domain goes to this spot. And your browser is caching all of those things, so that a lot of times, if it's a site you go to regularly, it doesn't even have to leave the browser. The browser knows where to send the traffic. So, yep, I found it. We're going to send it to this website. Perfect. But what happens if your browser doesn't know where this site is? Well, it doesn't know. So we're going to go to the next layer, which is our operating system DNS. So you're running Mac or Windows or Linux or whatever. Your operating system has a similar database of flat files sometimes of sites you look up. It's basically like a phone directory. So it's going to look there. Did we find it there? Yep, great. We're going to send it to the website. We didn't find it there. Okay, we got to go to the next level up, which means we have to ask our ISP or Google or whatever to, where does this domain live? Where are the name servers for this domain? Did we find them? Yep, we're going to send the traffic up to the website. Took a little longer to get there. But sometimes if it's a brand new domain or you just made some changes or whatever, it doesn't even find them in those recursive resolvers. It's going to have to go look at the root and authoritative registry. And so that sometimes even takes longer to happen. But eventually, hopefully, we'll find it and we'll send the traffic up to the website. If we didn't find it, there's some error with the domain. So this is, in a nutshell, how DNS works. It's going through these multiple layers. Every time you make a request, to try to find the name server so we can get to the website. And we're going to try to answer that question as close to the web browser as possible. But sometimes we don't know, so we have to go down the whole tree here of DNS servers. Now, once we get to the name server then decides where to send the request based on the DNS records that it holds. So are you looking just for google.com, or is it mail.google.com, or whatever? The name server has the list of all the different resources, all the names that are subdomains or whatever for this domain name, so it can send the traffic to different places. And again, this is just like the contacts app in your phone. So my contact in my phone, is it my mobile number, my home number, my work number, my email, or whatever? Like you say, call Nathan Ingram mobile, and it's going to go look at what that number is, boom, and it goes to find it, right? This is the same way DNS works. Okay, does that make sense, everybody? So there's a whole lot of things happening, oftentimes transparently, without the user ever really being aware of it, until the plumbing breaks. And now we have to be smart on how do we fix these issues. So let's start with the name servers. This is where the magic happens. Now, name servers, as we just saw in that little graphic, control the traffic for a domain name. So, and by the way, when you think about DNS, you're probably thinking about DNS records, which are controlled by the name server. So if you understand how name servers work and the different records that are associated with it, you're virtually there. Like, that's the lion's share of the kind of work that we tend to do when it comes to DNS. This is where we're going to spend most of our time. Now, domains typically have two name servers, and you'll see that. You register a domain, it's going to ask for a primary and secondary name server, or NS. And by the way, access to whatever is managing the name server for a domain, this should be guarded like your root password, because people can, like if that gets out and people get access to your name server, they can change all sorts of things, adding, malicious links or whatever. Super important to guard access to those name servers. Now, when you open up the world of name servers, it really comes down to the different types of DNS records. Now, there's a few common ones here that we'll look at. A record, probably the most common. It's a name that then points to a CNAME, to an IP address. So, for example, wpnathan.com, if you look at the DNS for WPNathan, it's an A record. It points to an IP address, and this server IP address. So the DNS, you're looking for wpnathan.com. Here, go to this IP address. That's what it's doing. Now, another type of record is a CNAME. And the only difference between these two, so like mail.wpnathan.com goes to ghs.googlehosted.com, which is a Google Workspace thing that Google Workspace provides. So the only difference between A and C names is that A records are pointing to an IP address, C names are pointing to another name. Like if what they give you is an IP address, it should be an A record. If what they give you is a name like googlehosted.com, that's going to be a C name. Neither one is better. It's just one is an IP address, one is a C name. Now, by the way, I've had people ask this question before. This is not forwarding. It kind of is, but technically it's not. This is not just forwarding mail.wpnathan.com to this address, because this entity here has to be aware that it's getting traffic. So it's not just like a forward where you can forward anything you want to any other place. The target has to be aware that it's receiving traffic. Like Google Hosted needs to know that mail.wpnathan.com is sending it traffic, and you set that up in its settings. Now, you might also run across MX records. These are email records for the domain that tell the traffic, how, if it's mail traffic, where do I send that? And if you're using Google Workspace, you're familiar with something like this. There's several of them and so forth. So A records, C names, MX records, text records. Now, the text records are used to verify or authenticate. They usually have a lot of random characters. But the good news is, If you can understand these 4 records, that's 95% of what we do. Like, it's most of what we do. I just made that number up, but it's most of what we do is right here in these 4 records. So these are not terribly complicated to understand. The A record sends a name to an IP address. The CNAME sends a name to another name. The MX record just manages mail, and text records are just to verify things. That's really, at the base level, most of what we do with DNS. Now, unpacking a few more that you'll come across, these are generally text records. You have all this new email authentication that has to happen here in the last few years. This has become required by most email providers. They're used to authenticate email from your domain. And we're not going to go deep into this other than to be aware of these records. They're going to be given to you by your email provider. One little pro tip here is that, and you'll find this can be a problem, if you're having trouble with email authentication, double check, because you might have a couple of different SPF records in your DNS because you've added one for Google Workspace and you added another one for MailerLite or whatever it's called now. And these 2 SPF records will conflict and cause problems. So the good news is you can take both of those records, drop them into your AI tool of choice, and they'll combine them into one. So that's super helpful. 95% of what we do is right here. A records, CNAMEs, MX records, and text records. That's really it. All of those records held by your name servers, and it gives it tells the browser or app where to look. That is the basic understanding of DNS. Now, what happens when things go wrong? DNS propagation creates much frustration. What is propagation? This is the time that it takes for changes to your DNS records to update back up that little scale, right? Up through all those layers. The layers that speed things up usually can also slow things down if you're trying to make a change. So it's like caching for websites, right? So many problems. Oh, my website doesn't look right. Well, we got to go empty the cache, right? Like something's gotten wrong with the cache. And propagation is it comes from this DNS caching that usually makes the internet flow pretty quickly. So every DNS record has a little feature called TTL. It's a setting on that record. TTL means time to live, or in other words, how often should we check back to see whether or not this record has been updated? And you may find a really long TTL. Some are a year. That's crazy. Some are, 5 minutes. But depending on how long that TTL is set for, that often creates a delay before any changes of that record filter their way back upstream through all the layers of caching until it's seen by everybody. That's just the nature of the internet. So I had an office hours question a couple of years ago that said, hey, why is it that DNS changes seem to take an hour to make? And the reason is because that's what you've told it to do. Your TTL was probably set for 3,600, which is the number of seconds, or 60 seconds times 60 minutes, 3,600, 1 hour. Yeah, you've told it to take an hour. So it's really important to understand this before you start making changes to DNS. So some name servers, depending on especially the root ones at the very bottom, the registries, can take 24 hours or longer to update upstream. So this is why some people may see changes that you make while others don't, because we're in this propagation period where it has to filter its way back up these layers of DNS to get to where everyone sees it. So it can happen at every level. It can happen at browser, operating system, authoritative, root level. All of these things can take time. So how do you deal with those and start to troubleshoot the issues around DNS? So we need to understand how the process is going. So let's say you make a change with one of your name servers, like you're moving hosting, and that requires you to change the name server on the domain name. This is often what takes the longest to propagate. So there's a great tool, and there are others. I'll give you some other examples in a minute. There's a great tool called whatsmydns.net. Now, I've been using this tool for many years, And what this allows you to do is just type in your domain name, and it will tell you what the name servers are for that domain name. And while a server is propagating, let's see if I can zoom in on this a bit. While propagation is happening, you'll often see a difference. Like some will be some IP address, others will be another. This is under Cloudflare, so it's showing 2 IP addresses. And for overseas, it's showing different IP addresses because this is based in the States. Anyway, so you can see this happening. And when all of your numbers start to line up, you can start to see, okay, DNS is slowly propagating across the internet. So this tool, whatsmydns.net, is your friend. Like this is one to bookmark and save as kind of the first thing to look at as you make a change to a name server and you start to see the propagation occurring. Very, very helpful tool. Oh, and by the way, this tool will also let you check the status of the most common types of DNS records, like a CNAME, text, whatever. Now, I just typed in WP Nathan, but look, there's this drop down. I can also look at MX records, CNAMEs, text records. So if you've got a value that you just added for a text record, you can put that in there and it'll show you the actual value right here rather than the IP address. So you can check the propagation status of any single DNS record with this tool by entering the name here and telling it what type of record it is, and it will it'll show you what's being actually found with a DNS query. It's a really powerful tool. It's totally free. Now, there are others out there that do similar things like dnschecker.org and dnspropagation.net. They all do basically the same thing. I've just always used What's My DNS. It's got a bunch of ads on it, but I don't see those anymore. I'm banner blind to those things. So super important tools to keep in your back pocket, keep in your toolbox for when you're dealing with a propagation issue. Now, here's where things can even get a little more frustrating, because even if the world is seeing, hey, the new website is up, or this change has been made, or whatever, you individually may not see it. And there are some reasons for that. So think your way back up that little graphic that I showed you. Like you've got the recursive DNS that's showing up on What's My DNS, but then there's the 2 local DNS servers on your computer that may not get updated yet, the operating system one and the browser one. So we need to clear, first of all, our browser DNS cache. Now, you might think that just clearing your browser history might empty the browser's DNS cache. It does not. Matter of fact, I actually like that because you, like me, probably have 800 tabs open, and I don't want to lose all those tabs, and I don't want to lose the sites that I've found and logged into, or my history of things that I've visited, that sort of thing. So this does not clear your browser history. It's completely different. So different browsers do things different ways. If you're in Chrome, you type in the Chrome browser, or you can just in the slides click this Chrome://net-internals #DNS, and it will take you to this page. This is the internal DNS database inside a Chrome browser. So we could look up here. What am I seeing for wpnathan.com? And it tells me what it is. Now, if I want to clear the cache, I just click that button. That's literally it. You don't get any sort of notification that it worked. It just clears it. wpnathan.com. Again, if we look it up, okay, just actually, it's not there. See, it didn't find it because we cleared the host cache. So sometimes, like, why is it that one of my browsers sees this thing and the other ones don't? Well, the internal DNS database of that browser needs to be cleared. Now, eventually it will clear itself when the TTL of the record in question times out and it refreshes. But if you want to force a refresh, you've got to go here, net internals, DNS, clear host cache, done. Now, if you're using Firefox as your browser, it has its own link about :networking #DNS. It's very similar. If you're using Safari, it's a little more complicated. You have to enable DevTools and do some things. I didn't want to take the time to do that here on this live stream, but you can Google it. There's a way to empty the Safari DNS cache manually as well. All right, so that's one local level. There's another local level that you'll sometimes run into. And this is the sort of thing that until I understood what was going on here, I was going absolutely crazy. Like the browser cache is empty, the recursive DNS is resolving like it's pointing to the right place and what's my DNS. Why am I still not seeing this? It was the operating system cache. So whatever operating system you are running, I have for the most popular two here, you can clear your operating system local DNS cache with a couple terminal commands. So if you're in Windows, you can open a command prompt as an administrator and enter ipconfig /flush DNS. That's been the command forever and ever. And it still works. And that's going to flush your all of the local DNS cache, and maybe that's going to fix the issue. Another one, if you're on a Mac, you just enter a terminal and you enter this really crazy long this. All of these two sudo commands, and it's going to ask you for your password, and then it will flush your cache. Now, little pro tip here, if you are hopefully you're using some sort of macro app on your computer, with a quick macro stroke, it'll explode maybe these commands out. I use that for the Mac terminal and other places where I just hit the button and it clears the cache. It's super helpful to have this stored so you don't have to remember these long, gnarly terminal commands. So we got to wait, make sure our all of the internet world has resolved, and we look at our browser cache, we look at our operating system cache. Now, in the meantime, let's just say we've got there's a major change that's happened. Like maybe I just bought a domain, or I'm changing the name servers of my domain. And that can take a little while to propagate, because especially a name server change has to enter at the root, like the root level at the registry, and then work its way back up. So those can take a while. It used to take a day. Now sometimes it takes an hour. But it does take, it's not instant by any means, or 5 minutes. It takes some time, especially if you change a name server. So until then, there are a couple of workarounds you can do. And this one you've probably heard of before. You can edit your host's file on your local machine. Now, again, think all the way back when the internet was a text file. And on ARPANET, they had the location of all the servers and their IP addresses on a single text file that was sent around to all the computers in the network so they would know where to find each other. Well, your computer has a similar thing today. Even 2025, 50 plus years later, there's still a text file on your computer that is a lookup. So this is the hosts file on my Mac. And basically, it's defining local host and broadcast host up here. But down here, you see, let me zoom in. Literally, you can just put your own list here. You can edit this, and there'll be an IP address, space, and domain name. Now, this has a hash in front of it because it's commented out. If I were to take this out, whoops, now I've lost it. Hang on just a minute. We got to find it again. If I were to take that out, sorry, folks. Too many things going full screen here. If I were to take that hash off and save it and then clear my operating system cache, my computer would start looking for WP Nathan at this IP address. And you can just space these out all the way down in a host file and have your own little directory here. And it's literally, there's nothing else, just IP address, space, and the domain name. And so this lives on your computer, and you can make a change in the host file. Now, there's a process to doing this, and there's instructions for both Windows and Mac. Here, I'm assuming if you are on a Linux machine, you know how to do this already. But if you want instructions on how to do it for Windows and Mac, those are linked here in the slides. So your computer, your operating system, has its own mini DNS server there called a host file. Now, there's another tool, and this is super cool. I've noticed a few tools like this popping up around. This is one I promise you're going to want to put in your toolbox. It is a tool called hosts.click. Now, hosts.click, I don't fully understand the magic that goes into making this work. They have their own like mini DNS server, I'm assuming, but basically you put in the IP address of the server that has where your domain name is going to live. And then you enter in your domain name. So I could do like this 192.0.0.1, whatever, for just whatever IP address and make that wpnathan.com. And when I click here, it's going to generate a preview URL. It may not like this address. Oh, there we go. So here's this preview link right here. It lasts for 10 minutes. And if I click this, it is as though I've edited my hosts file. So it's going to, that link takes me to wpnathan.com, but on that IP address. So even though wpnathan lives someplace else, this little tool creates a preview URL so I can view it over here at the location that has not yet propagated. This is a crazy good tool, and it's totally free. There are others that you can pay money for, and you get permanent links and things like that. This is a great free tool that gives you a 10-minute window to check all the things and make sure the site looks good, even before you point the DNS there. So host.click, what a great tool, totally free, highly, highly recommended. All right, does that make sense? I'm going to pause quickly if I don't see any questions in the chat. So I'm going to press forward. We'll have a good time of Q&A at the end. And by the way, if you have questions through any part of this, just use the Zoom Q&A, and we'll get to those questions as we wrap up today. Now let's unpack a couple of additional common DNS problems. Now, the first problem that comes up a lot is, where is the DNS managed for a domain? Like, how do I find out, if you're working with a client, for example, and you're trying to, you're eventually going to launch a website on their domain. Well, where is the DNS managed? Is it at the registrar? Is it at the host? Is it someplace else? How do we find out where the DNS is being managed? The key to this is the name servers. So if we figure out where the name servers are, that's what's managing the DNS records for the website, right? Because that's the job of the name server. It has all those records in it. So what we're going to do is do a whois search on that domain name. Now, whois is it's actually part of ICANN's requirements for any registrar. Anybody that you buy a domain from has to provide a whois search. It's part of the deal. And so you can do this actually through your registrar. You can go straight to ICANN if you want to and do a lookup there. I've given you the link there, so we could go right here. And the thing I like about doing it through ICANN is you don't have 8,000 ads like a lot of the registrars put out there for you, or have to click through a bunch of different captchas. So we're just going to do wpnathan.com here, and we will get the whois information. Oh, look, here's our name servers. They are at Cloudflare. So that reminds me, oh yeah, I got to go get access to Cloudflare for the DNS. Does that make sense? Now, you can also use a terminal command if you're on Mac. If you are on a Mac, Mac terminal supports a whois query. And I've got to find the window. Here we go. All right, so here is a terminal here on my local computer. And I just type right here, whois wpnathan.com. And boom, it gives me all of the whois information right here on my Mac. And I can just scroll up until I find the name servers right here. So that tells me, it's there at Cloudflare. Now, this just works on any Mac. If you have a Windows machine, I think it works on Linux too. I'm not a Linux person. But if you're on a Windows machine, you can get this, but it takes a download. So you've got to go to Microsoft sysinternals and download a tool and go through some rigmarole, but you can also get a whois lookup for your command prompt if you want to. So once we figure out, okay, the name servers are at Cloudflare. Okay, now I know I need to get access to Cloudflare, right? Now, sometimes you're going to get a name server that isn't recognizable. Like if you have a domain that uses GoDaddy's name servers, it's going to be something.domaincontrol.com. It doesn't say GoDaddy.com. You just have to figure out that domain control is GoDaddy. And the easiest way to do that is just Google it. who uses domaincontrol.com for their name servers, and you'll find the answer. Or ask your favorite AI tool. They're really good about coming up with those sorts of answers. So this will point you to the right place. Okay, I need to get access to this in order to get into the DNS for the website. So finding where DNS is managed is sometimes a bigger pain than it would seem to be, but this is the way to do it. Figure out where the name servers are, then get access to the website that's behind those name servers. Oh, and thank you, Jeffrey, right there in the chat has dropped in the sudo command for getting whois on a Linux machine. Very cool. Just works on Mac. So I'm kind of spoiled to that. So that's our first common problem, figuring out where in the world DNS is managed. Here's another one I get a lot, which is, okay, I just added a subdomain on my web host, but it's not working. Like nothing's going there. It says it can't be found or whatever. Now, this is a common issue when you set up a subdomain on the hosting, but you didn't tell the DNS, the name servers, that subdomain exists. So the subdomain has to be defined with a record on your name server so that when the traffic comes there, it knows what to do with it. So you have to have an A record or a CNAME set up in the name server to point the traffic to the right spot for the subdomain. It's not just going to automatically work unless you're in a hosting environment that has kind of dealt with that for you. In general, it's not going to work. It has to be defined at the name server with a DNS record. Now, here's a pro tip. We do this whenever we set up DNS for a website. We always put an asterisk record, a wildcard A record. Let me just show you what this looks like. So I'm going to pull over Cloudflare DNS here for WP Nathan, and you'll notice right here at the top, there's an A record with an asterisk, which means anything that's not otherwise defined, it's going to send it to the IP address of the server. With a wildcard record like this, we can just add whatever subdomain we want on the server, and traffic is just going to automatically go there. Because what this wildcard record does is it says, if there's any subdomain or whatever .wpnathan.com, send it over here to this server because it's going to catch the traffic for that. Now, what you'll notice is, or like we could add another, like, or right here, this wp.wpnathan.com you see is going to a different IP address. So the wildcard record doesn't mess that up. This is actually a test site on rocket.net. So wp.wpnathan.com goes to a different IP address. The wildcard record doesn't get in the way of that because it says if it's not otherwise defined, send it here. So setting up that wildcard record, really, really helpful long-term. That also lets you spin up a staging site without having to define the staging record, that sort of thing, without having to get back into the DNS to add something. So if your subdomain isn't working, that's probably why, and a wildcard record is your friend. Okay, let me give you a few pro tips as we're starting to land the plane for today. These are things that I have messed up in the past and hopefully will not mess up again in the future. So my first pro tip is don't use your web host to manage your DNS. Now, many web platforms will allow you to manage the DNS for the website. cPanel, for example, it's what we use here at hosting.com. It's what my server at hosting.com uses. I like cPanel. And you can manage DNS at the server if you wanted to. I would recommend that you don't, because all this does is add a bunch of extra overhead work that the server has to do with sorting out web traffic and all these things. And it can complicate future migrations, because if you move it to a different server, if your old server was doing the DNS, now you got to update the name servers. And that means it's going to take longer to propagate, right? It's got to go filter its way all the way back up through the layers of cache. So yeah, don't do DNS at your server. And like Melanie is saying in the chat, there could also be some security implications to this. So you really want DNS to happen up at the network level before it even gets to your server, so that bad traffic can be filtered out. So it's better to manage your DNS with some third party. That could be your registrar. Many registrars offer DNS free if you have a domain with them. There's other services like EasyDNS or Cloudflare. So that's what I would recommend. Don't do DNS at the server. So there's a question in the chat. I'll address it now. So we should not let hosting.com manage our DNS. I don't, simply because it depends on how hosting.com is managing your DNS. I prefer to manage DNS with a third party to like offload that work off of my server. Now, I want my server to be serving, not doing DNS. So there are third parties you can offload that to at no cost. So your server doesn't have to do that work. And that leads us to the next pro tip, which is use Cloudflare for DNS. Cloudflare is the solution. I've been using it for years now. It just makes everything better. It's my recommendation. Security, performance, SSL at no cost, unless you want to add some of their premium services, which we do for a couple of sites, but most of them, the sites we manage, don't require any premium service from Cloudflare at all. Cloudflare gives you really, really straightforward DNS management. You can see that here. This is what the DNS area of Cloudflare looks like. And the thing I like about it is that you can even add a comment to yourself to remind yourself why you added that record in the first place. It's really, really handy. Also, by default, let me pull this back over. The TTL for Cloudflare for all of their records is set to auto, which if you hover over the little information icon here, it says 5 minutes. So by default, all Cloudflare records are set to refresh every 5 minutes. So the most you'll ever wait for propagation is 5 minutes, and I can handle that. Now, the exception is if you move the name servers away from Cloudflare, then, but as long as Cloudflare is controlling the DNS, and they are managing your name servers and the DNS records, all records propagate within 5 minutes. So there's very little downtime or delay. That's one of the many reasons that I recommend Cloudflare for DNS. Now, let me keep going. I see some great questions coming in, and we will get to those momentarily. Next pro tip is if you're going to change a DNS record, lower the TTL prior to making the change. So if you want to avoid propagation delays, then you need to set that time to live lower before you make the change, usually about a day or so before the change is made. So again, if you're not using Cloudflare, lower the TTL of the record the day before is a rule of thumb. And then make it as low at that point as that DNS provider will allow. Now, some DNS providers will only, like the lowest they'll let you do is 1 hour. But you want to get it as low as you possibly can with the provider that you're using. That's just going to speed up the propagation process. Oh, and make sure you change the TTL back later, especially if you're running DNS at your server. Because think about this. If you're running DNS at your server and you have all your records set for a 5-minute TTL, then every 5 minutes for every one of your sites, every single one of those records has to update. And it's just so much overhead processing things going on. It's just not an efficient way to use the horsepower of your server. All right, another pro tip. If you need to discover all the DNS records for a domain, here is a really, really great tool called DNS Checker, which I can't currently find. Just a minute. Too many windows. Okay. So this is DNS Checker. The slides are linked. I can do wpnathan.com, and it will find many of the DNS records for the site. Now, notice it only found one TXT record, and that's pretty normal. But if you look at the actual DNS records for the site, there are several. So it is normal for some of these external DNS checkers to miss the TXT records, the text records for a domain. They're usually going to be pretty good about catching the A names or C names and MX records, but they frequently miss TXT and other validation type records. So this tool can be helpful in a pinch, but if you really need, like if you're moving name servers from one place to another and you need a real, like a carbon copy of all the DNS records over, you really need access to the DNS platform that it's on now. So can be helpful for a couple of things, but you really need to get access. Which brings me to this one. Back up your DNS records. It is a good idea to store a backup of a site's DNS records at launch or after you've just made some changes. Just have a Google Drive folder, have some place secure that you can put DNS records exports for the client sites that you manage. For example, here, I can go to DNS, click export, and export this entire zone of records out of Cloudflare into a file, and I can save that someplace. Just make sure it's not accessible to the world, because there is some validation information here. So store this someplace on your computer or some secure storage, but that way, if something happens, you've got a backup of the DNS records. And you never need a backup of a DNS records until you need a backup of DNS records. Yeah. So many registrars do have export tools. You just saw the one for Cloudflare. If export isn't a shot, a screenshot is okay, but better than that is doing a PDF print. So just print the page out of your browser and save it as a PDF, because if it's a PDF, that's going to let you copy and paste the text. It is a really bad day if you've got to hand jam in one of those really crazy long TXT record validation strings. So print it to a PDF. That's really good. All right. This is agency related. Super important to get DNS access early in a project, because sometimes it can take a while for a client to get you access to their domain or to their DNS provider. It can just take a while. So what we do is at the very beginning of the project, we have a technical questionnaire that we give to our clients that gets access to all the things we're going to need access to. That goes at the very beginning, so that as we're working for the next few weeks on the project, it gives the client time to gather that information and get us the access that we need, because it's really bad when you're ready to launch a website and, oh no, we don't have access to the DNS or the domain or whatever. Just get all that stuff at the beginning. It's going to save your time. Now, we got a lot of great questions that have popped in here, but I want to leave you with the best pro tip of all, and that is to upgrade to hosting.com. I host with hosting.com personally. I pay for it for my agency. Like, it's my choice to host there. I've been thoroughly pleased with the hardware that it's provided. It is incredibly fast. We use a virtual dedicated server with hosting.com. There's also virtual private server options. All that hardware is refreshed with the latest hardware on a regular schedule. And if you want a more managed hosting approach, you can go with managed WordPress hosting by Rocket.net. Rocket.net is now part of the hosting.com family. And the good news is, as an agency, whether you're a team or an agency of one, you can have access to my friend Mike Demo, who's going to give you straightforward answers and help you find the hosting solution that's right for your business and your situation. He's also there for the long term. So he'll be your agency advocate. So if some issue comes up, you can talk to Mike directly, and he can usually clear a logjam for you. So I would encourage you to scan the QR code to schedule a conversation. You can just call him right there and leave a message on his voicemail, and he will find time that works for both of your schedules to sit down and talk through your needs for your agency. All right. This has been fun, right? You survived demystifying DNS. We have a few minutes left for questions, so let me get to those, starting with an anonymous attendee who says, I assume we can get a recording of this to review later. And absolutely. So I'm going to drop into the chat our link bundle. You'll see that in the Zoom chat now. And in that link, you'll see the agency success replays. Now, it's replays.myagencysuccess.com. That takes you to the YouTube playlist where all of our agency success live streams are stored. It usually takes a few days for this recording to get up there. But yeah, I would imagine by the end of this week, it'll be up there for you to view. And we do that with all of our live streams, including office hours, which we have every Thursday, where you can ask any question that you would like. All right. Next question. By the way, if you have a question to ask, just use the Zoom Q&A and I'll get to it. We're down actually to the last question now from Stacy. So Stacy says at another host, she uses the domain dashboard for the DNS for websites that are not on Cloudflare. Is this what you mean by manage at the network level? Okay, that's a great question. Because we use Cloudflare, I'm not even sure how hosting.com manages DNS. My point in saying don't use your host for DNS, a more precise way to say that would be don't use your server. Like if you're on a cPanel server, for example, don't use the cPanel DNS tool to manage DNS for the domain. It works. It's just not the best option. And that's what I was talking about when I was saying it consumes server resources to manage DNS if you're doing it that way. Now, at the host that Stacy is describing, and I'm not sure how hosting.com does it, but some hosts have a tool that lets you manage DNS, not on your server, but in the host's network. That's fine. My emphasis was just don't do it on your own server. Use your server resources for serving websites, not for managing DNS. Great question, Stacy. Andrew, is it free Cloudflare for a domain verified SSL? Oh, great question. So, well, I'll just show you. So let's go to wpnathan.com, which is behind Cloudflare. And as we look at the certificate, what you will see is that it is a Google Trust Services certificate. So this is the one supplied by Cloudflare to visitors coming in. Now, also on our server, we have Let's Encrypt running. So from the server, it's encrypted with Let's Encrypt. Cloudflare gives the SSL to the world from Google, and Cloudflare network makes it all work together. So it's fully secure from end to end, but Cloudflare currently uses Google Trust as their SSL provider. Andrew, did that answer your question? All right. I'll pause just for a moment to see if, are these SSL certificates okay for e-commerce? Wonderful question. So there are still companies today that will sell you SSL certificates for $100 a year. Please don't do that. Please don't do that, because those certificates are technically exactly the same as the free Let's Encrypt or free Komodo SSL certificates that cPanel generates, or the Google Trust certificate that Cloudflare provides. Technically, they are the same level of encryption. Now, there are higher levels of encryption that you can purchase for extremely sensitive financial situations. Think banks and things like that. Now, those are, they're more highly encrypted, and those can cost hundreds of dollars a year. The average website doesn't need that. An e-commerce site doesn't need that. They simply need the normal SSL certificate. So you shouldn't have to pay for an SSL certificate. If you're paying for an SSL certificate and your host doesn't give you one for free, find another host. Hosting.com provides SSL certificates with Let's Encrypt with all the servers. Cloudflare provides Google Trust for free, and it manages that for you. So yeah. Andrew, does that help? Sherry has a question. Is it good to use the embedded Cloudflare connection within a hosting environment? They have a CDN in their hosting service versus going outside of hosting to set up Cloudflare. Okay, Sherry, I'm not precisely sure what you're asking. So let me answer it this way. I think I understand what you're asking. If your host provides a CDN, should you also use Cloudflare CDN? And the answer is no, don't do that. Two CDNs can make things goofy. Within Cloudflare, you can turn off caching that fills the CDN with some rules. However, many hosting or other CDNs require you to set the name servers for that CDN. So you can't use both. Because Cloudflare requires its name servers to be on your domain. So at that point, you have to decide which one do you want. Sherry, should you ignore the internal CDN connection? I have to understand more what you mean by internal. This sounds like a great office hours question, Sherry. We have more time to get into it there. But the bottom line is this. Usually a CDN is going to require that the name servers are set for that CDN. If it doesn't, that's fine. You can still use Cloudflare. I just would turn off the caching and the CDN. It can really cause some issues. Rob, currently I use cPanel to do DNS. What would be the steps to move to Cloudflare or some other third-party DNS? So there is, you basically it's two steps. You're going to make sure you can get the DNS records out of cPanel. Now, for whatever reason, it's been a request for 7 or 8 years now. cPanel inexplicably does not offer an export tool. There is a way to get it. It's beyond the scope of this live stream for me to show it, but you can get the export file out of a cPanel. So you're going to want to make sure you get your records. Then all you're going to do, like for Cloudflare, for example, create a new account, set up your DNS, add all the records. Once it's set, you'll take the name servers that Cloudflare gives you and put them on the domain name, and that will start to point the traffic over. That is a very, very simplified explanation to a more complicated process, almost too simple. It really deserves more time than I can get into here on this live stream. What I would suggest, this is something we might be able to show, Rob, in an office hours. This is why we do office hours, to really have more detailed questions and take the time to unpack those. That happens every Thursday at 1 o'clock Central Time. I'm going to drop our links bundle back in the chat for the upcoming live streams. That very first link, you will find the link to register for office hours at the very top. So right here, every Thursday, agency office hours, click that and sign up, and it's free, and just come join us and ask your question there. All right. That's it. I believe that wraps up our questions. So thank you for enduring the world of DNS. Hopefully you've got a little more clarity on some of the complicated matters that run the plumbing of the internet. So hopefully you have a bit more confidence. I hope you've enjoyed it. Really appreciate you being with me for the last hour. We'll have this replay up in a few days on our YouTube channel. Thanks so much, and I hope to see you back here for office hours, Thursday, 1 o'clock, here on Hosting.com's Agency Success, where we go further together.